easy topic, scoring chapter. And of course that happens for all the chapters, but this is one specific chapter where there is only one formula, and in that also there is kind of, probably it's one whole marks for the formula itself. So formula, writing the formula is compulsory, and for the most questions you might tell the answers just trying, mentally you can solve, but there are 3-4 steps that you need to write, and that would give you marks. Although you'll get answers pretty quickly, but don't underestimate. Please do write the steps, and that should be good. So what's the meaning of this word probability? Anyone? Probability.
The chance of an event happening. The chances of an event happening.
Oh, you're talking too technical. Event. Okay, something happening. What are the chances? What are the possibilities? What is the probability? That is what probability means, and probably you understand that well. So okay. So there are two things here. Okay, maybe we'll first discuss the formula and then come to the rest of things. So probability of anything, of an event. You talked about events. So probability of an event. So suppose we are tossing a coin. So it has two faces, head or tail. And by the way, a disclaimer, this origin of probability and statistics, you will see a lot of examples of coins, cards, die, all these things. So its origin is not so good. I mean, it kind of originated from the places near the clubs and all, maybe even that. So the Europeans found this out, and that's how it originated basically. So you will have a lot of examples, not so good, but this is what we have. So anyone played cards? Tried cards? Any card players? Oh my god. Okay. So sorry?
The friendly one with family.
Of course, you don't have money. So probability of any event is number of favorable outcomes. Now what is this favorable outcomes? It is the result that we want. Outcome means result, and the result that we want. So favorable result or favorable outcome by total number of outcomes. This is the formula that you can get 1 easy marks out of 80 marks in your math test. So this is it. Just remember it. I mean, don't write number NO and write the number NUMBR, and probably you'll get 1 marks. Okay. Next, here if you want to find the probability of getting an head, so P of H. So number of favorable outcomes, how many favorable outcomes do we have out of H and T? We want head, so there is only one possibility of head out of these different situations, outcomes that we have, and then total outcomes were 2. So the probability of getting H is 2, and same goes for T also, 1 by 2. This is what we studied in 9th. Probably no one should have any difficulty at all. Now what we found is this is called theoretical, okay, probability. Now if something is theoretical, there should be some practical or experimental, empirical. Empirical means what tangible. You can try that. You can experiment it out. So second one is empirical or experimental. Now, what does that? How does that differ from this one? So this we took for any general case. I mean, that's what you will get. You will get half probability for getting head and half probability for getting a tail. But now if you're tossing a coin 1,000 times, so what should be the probability of head? It should be half, right? The probability should be half, and probability of tail should be half again. Is that okay? But if you really do that, you continue have that much time and you toss the coins 1,000 times. So you are not going to end up exactly, maybe for the most part not, isn't it? So you will not get, maybe you will get 455 heads. So this is one case they have. So now the probability would be what? Favorable is 455, total is 1,000. So probability would be 0.455, right? It's not half, it's not 0.5, it is 0.455. So that means this is the experimental probability. So hope you are able to understand the difference. Theoretical means it's an ideal case, and experimental is basically experimental. You try it out and that's what you have. So for our case, we will be only considering the theoretical probability, all ideal cases. Okay, will not break our heads trying flipping. Okay, I saw a video. Maybe if I see, I'll share that. There's a video of someone tried. Okay, yeah, he was flipping the caps. It would be facing upwards or downwards. He had maybe 100, 200, 300 caps, and then he tried that experiment. So that is theoretical probability.
So,
Yeah.
like, when you're flipping a coin, that time the possibility of getting a head or a tail, both of them is 1/2, right?
Huh. Right.
So how can that I couldn't understand the 4,555,000.
This is if you toss it 1,000 times, you got head 455 times. This is what they did. They flipped it one time. Okay, one head. One time again head. Okay, two. And a third time. Okay, this is tail. So two one. Head is two, tail is one. Like that they found that. And this is what they got in one of the experiments. This is not universal experiment. This is one of the experiment. We would have got maybe 499. Maybe we would have got 100 head. That is different thing. Now the thing is,
It's random.
yeah, it is a random experiment. It's a random experiment. Now the thing is, the more you do, the more you toss the coin, more number of times. Maybe if you do it 1 lakh times, so it is understood that it is expected that it would go near to this 0.5 value. Here it was 0.55, 0.455, and if you that's for 100 times. If you do it for maybe 1 lakh times, it would be maybe 0.479. Who knows? If you do for maybe more number of times, so it would approximately tend towards the half value, the ideal value. Okay. Theoretical approach and okay, this was the formula. So this is also known as classical probability, theoretical probability. So P of E, number of outcomes variable to E, number of total possible outcomes of an experiment. Nothing sophisticated, it's the same exact thing. Okay. So first you can do easily. Okay, let us go to our try the second question.
Won't all of them be 1 by 3?
All of them is 1 by 3. Why to take so much trouble at the first place then? Okay. Everyone got this? 1 by 3 for all 3 parts? Yes? Sheeta, you also got this? Sheeta, you got this? Okay. This is 1 by 3. This is 1 by 3. This is 1 by 3. Let me erase that for a moment. I don't trust netizens. So
So, sir, say a question like this comes in exam. So, for all the questions, do we have to write the formula? Like P
first
event
time,
number of.
first time, suppose you have 2 probability questions in the whole paper, 12th question and 25th question for that matter. So you have to write, and it has three parts for all of these. So for the first time 12, you have to write the formula. In the 25th question, first time you have to write the formula. So then 3 parts you can get away without writing. But there you have to write the number of outcomes. We'll discuss. Suppose for if you have 2 coins, so you'll have HH, TH, HH, TT. So like that. So there you have to write that outcomes. That is compulsory. So we got 1 by 3, 1 by 3, 1 by 3. Now, do we have any other thing, any other possibility, any other event possible in this situation? There are only 3 cases, right? No other event. Now, this is these are called elementary events. And it is what it is. These are elements that make this whole experiment. And the important thing is we don't have any other option left. That is the important thing. If you have consider all the elementary events, we shouldn't be left with any other missing this thing. If it was a 4th ball also, and we did only these 3 questions, so the 4th elementary event would be left. But here it is, these 3 elementary events are there. Okay. So elementary events are the sub events. Getting yellow ball, getting red ball, getting blue ball. Fine. Now, what's the use of this? We have a utility. If we add all the probabilities of elementary events, we'll get the sum as 1. You can see P1, P of orange, P of red, whatever it was, red, green, blue, whatever. If you add, you'll get 1 by 3 plus 1 by 3 plus 1 by 3 is 1. And again, the only important thing we need to remember is everything is included or not. There are only 3 elementary events, and we are safe. You can add. But if there was a 4th thing, and you would not end up getting it equal to 1. So sum of this is the second formula for this. I mean, now it is whatever you call it, a remark, note, whatever it is. Sum of probabilities of elementary events. Let me write all elementary events. All elementary events equal to 1. Okay. This is the second thing. First is formula, second is this. There are 2 more small notes, and that's the whole chapter basically. Now, this is done. Now, what's the use? Suppose you are given the probability of red ball is 1 by 7. You are given the probability of green ball as 2 by 3. And you are required to find the probability of whatever blue ball is. Can you find that? And we are given these are the only 3 elementary events. Can you find the P of B? Yes, no, no.
So could you just tell me once what is that sign? The E is equal to 1.
Probabilities of, okay, this sum we added na, probability of first, probability of second, probability of third.
Yeah, the yeah, right above that you've written EPE is equal to 1.
That's what I'm talking about. This is sum. So whenever we have something like this, x1, what does it mean? We have to add values of 1 to maybe 10. So add the values of x1 plus x2 plus x3 till x10. That's what this summation means. Add all the values of these series of numbers for xi starting from 1 to 10.
Okay,
Works?
works.
So it is summation. So summation of all the elementary events probability is 1. So it is not necessary we would have 3 events, right? We could have 100 events. Who knows? So P of sigma P E is equal to 1. So yeah, I was asking, can we find the P of B? Yes, no. Okay. Tell me, Nia.
So we can just write it as 1 by 7 plus 2 by 3 plus x would be equal to 1.
Is equal to?
1.
Okay. Sum of all the elementary events probability is 1 and x would be maybe 2 by 3, whatever it is. Okay, you can find it. Nandita, is that okay?
Sir, elementary event as in we know that how many outcomes are there, right? Like how
We
many total.
we don't know, but this is what it is given. That red, green, and blue were the elementary events, like in the second example, second question also. So don't worry about that. They will not. They will not assume that they would hide a elementary event from you and they would ask for that. That's not valid. They would give you all the. I mean, there could be questions in which it would be hidden that you need to figure it out. That is also possible. I'm not talking about that type of question. I'm basically, here it is very clear. Three things. है ना?
Yes.
Just give me. Okay, so the thing is, sum of elementary events is probabilities is 1. Now, uh, okay, we'll see. Fourth, you try this question. I'll be back. Fourth. Okay, anyone done with this? No. Okay, so Shita, try.
For the first one, I got 1/2.
Okay, so this is one of the starting cases where you could write the outcomes also. So this is how we need to write the solutions. First thing, probability of getting a number. No, getting a number greater than 4. Yeah. So same number of outcomes divided by number of that thing. So what are number of outcomes?
1.
Not number of outcomes.
Like a
Outcomes. Outcomes. What are the outcomes? So what are
number
the
of
favorable
favorable
outcomes? Favorable outcomes is
yeah,
what are that? What are
is
those?
1. 1.
Only one. When we throw a die,
Yeah, yeah.
you
The
have a die.
possible number of outcomes is 2,
You have a die
right?
with.
Because you could
Okay, tell me how many, what are the numbers on a die first. I don't know if you have a die with 5 sides. Okay, tell me.
6.
Okay,
6.
6. Tell me. Tell me. 1, 2, 3, 4, 5, 6. The total is 6. Total. I already wrote that. So this is all outcomes, all possible outcomes. So, and favorable
But
outcomes. Yeah. Ah.
uh, but the number of favorable outcomes, I wrote 1 because
Hmm.
the probability of getting a number greater than 1 is you can either get 5 or 6, right? But you can only get 1 after rolling the dice, right? Either 5 or 6. So I wrote 1.
Okay, that's intelligent and confusing. So, favorable outcomes means what are the possible numbers that we can get. It's not we'll get two at the same time. Okay, it is possibility of what and all you can get one at a time. So you can get maybe 5, you can get maybe 6. So these are the two possibilities, right? And total possibilities were this. So 2 by 6. Don't write 5, 6, 11.
Oh,
Okay.
okay.
Second one, Nandita,
Sir, it's 2/3
2 by 3. How did you get that? What you got?
because the probability of getting a number less than or equal to 4 in that favorable outcomes are 1, 2, 3, 4. So there are
1, 2,
4
3, 4.
favorable outcomes
Ah,
and divided by 6.
4 by 6. Okay. Now, any doubt with this? 2 by 6, 1 by 3, and 2 by 3. Any doubts? Now, it is not that you would have a lot of elementary events and then you add up and then you get the sum equal to 1. See, these can be considered two elementary events because they complete the whole set of that experiment, right? Either you could get greater than 4, so 5 6, or 1 2 3 4. So these just two things completes all the sets. So these two can be called the elementary events. One is getting less than equal to 4, another is getting greater than 4. And what happens when we add the probabilities of elementary events? 1. So you can see 1 by 3 plus 2 by 3. Make sense? Nandita? What does that mean? That means if These are known as complementary events. So complementary events means just two things, true or false, pass, fail, win, lose. So if a person's winning probability is maybe 0.79, so what is the remaining elementary event? There is only possibility of losing. I mean, the other part is counterpart is losing. So P of L would be what? 1 minus 0.79. Is that at all making sense?
So I don't know if it's valid, but sometimes it's also a draw, right?
Sometimes it is.
A draw type.
Come on. Then it is 50-50, na?
Yes.
It's 50-50. So thing is, you could have elementary events 3, 4, 10, 20. That is possible. Or you could create a, I mean, binary kind of a situation. Then also it could be counted as two elementary events and the sum would be 1. So complementary events probability sum. Okay, let me write it. This is the third thing. So third note. Uh, Probability of E plus probability of E dash, or sometimes it is used E bar. So probability of complementary event, two complementary, there would be two of obviously, that is also equal to 1. Okay, so what did we learn till now? Probability formula, number of favorable outcomes divided by total number of outcomes. Theoretical probability, empirical probability, or experimental, or yeah. The theoretical is also known as classical, by the way. Theoretical, classical. Second is empirical, experimental. Second thing. Third thing is sum of elementary events, probability is 1. Next, uh, complementary events probability is 1. So we will do this card thing next time. I will share the image, or maybe today. Let's see. Sixth one, only 1 minute, maybe 30 seconds.
Thirty-eight 0.30 is 0.38 is the probability of reaching my winning limit.
1 minus winning. Okay, P of W. I already did that for you. Seventh. Okay, anyone's birthday coming up? Let me check. Going forward, we'll not focus on the formula that you focus while in the exam, but we'll do it quickly. Skip steps. Okay, so first one, anyone?
Two by 360.
Sorry,
2 by 365.
2 by
360.
365 or 3.
36. No, what you have written is what
I have written 5. What are you talking about? It's
5.
3 or 5? 5, okay. Okay, what I have written. Okay, okay. I thought you were asking what you have written. Okay. Okay. That's interesting. How did you get this 2 by 365?
Because
Even I got the same.
Let's see. Favorable number of outcomes when we have different birthdays. So,
364 by 365.
okay, why did you change?
Because, sir, I don't know how to explain.
That's not answer because I don't know how to explain. I changed my answer. Okay.
No, it's because that if they have the same birthday, then it's 365 minus 1.
Yeah, same birthday means the same day. Either
Yeah.
Jan 1, Jan 2, Jan 3, February 30, whatever it is. So, it's going to be on the same day. Only one day out of 365 days. But if you have different birthdays, so first can have on January 1st, the other person would have the liberty of how many days? 364 days. Therefore, it would be 364 by 365. Nia, is that okay? Sheta?
I couldn't understand.
If you have a birthday falling on 1 Jan, so what is the probability of having the birthday on that same day? Out of the 365 days, total is 365. How many days you can have the birthday to have it on the same day? How many possibilities?
This you can have one possibility in any day of the whole 365.
Yes, any day you take, either you take December 31, December 20, whatever it is. It's going to be just one day. They could have the birthday on the same date, right?
Yeah.
So 1 by
Yeah.
365 is on the same date, same birthday for the same birthday. Now if you have
Yeah.
it
I
on
wrote that.
different, huh?
I wrote that. I was
Okay.
asking for the different birthdays.
Huh.
I wrote 2 by 365, but you said it was wrong.
Huh. So
So I didn't.
now we could have on 1 Jan. So can this person have on this 1 Jan? He or she can have on remaining 364 days, right?
Yeah.
2 Jan, 3 Jan, 4 Jan, 30 December, 31 December. Total 364 days. So what options we have for having a different birthday? We have 364 options, right? Possibilities.
Yeah. Okay. I got
That's
it.
how you.
Yeah. Got it.
So I don't think I've taken that question. It stumps a lot of students. Find the probability of Sunday probability of 52 53 sorry 53 Sundays in a leap year. It was a pet question of CBSE 8-10 years ago, but it has a lot of details in itself. So just give it a try.
Sir, 53 by 366.
How much?
53 by 366.
I'm sorry, come again.
53 by 366.
So after this much time you had classes with me, do you really think that I would give this question? I mean, which would have this answer? Really? Thank you for the appreciation. How many weeks we have? You'll get confused if I give you more time. Probably. So I'll just help you with this. How many weeks do we have in a year? 365 days or 366? How many weeks? Anyone knows?
52.
52.
52 weeks. So 52 weeks, and how many days are left? Okay, let's talk about 366 days, leap year itself. How many days are left now? It is 364, right? So in this 52 weeks, how many Sundays would be there? (52 weeks, 52 Sundays, right? So it's not really a concern for this. This is 100% probability. This is one probability of getting 52 Sundays. This could be a different question. 52 Sundays is one. You're 100% you're going to get 52 Sundays. Now, the trick is for the 2 remaining days. So what could these 2 days be? It could be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. So, how many cases? 1, 2, 3, 4, 5, 6, 7. We have 7 options. Out of these, how many possibilities of Sunday? There are 2 possibilities. For the 53rd Sunday, For the 53rd Sunday, 52 Sundays are already done. We are talking about the 2 remaining days. So 53rd Sunday could be any case out of these, any 2 cases out of these 7 cases. Is that making sense? No. Shita. Nandita.
Sir, I didn't understand how we got 364 days.
52 into, you should ask that time. Why do you stay in doubt for long? You can stop me. 364 days.
Okay, so we need to know that there are 52 weeks.
We need to. So you can divide, na? 7 days. So 364 is 52 weeks is not a concern. Short, these many Sundays. Only concern is the remaining 2 days. What is the possibility of the 53rd Sunday? So we have pairs of the 2 days, and we have 2 out of the 7 possibilities where we can have Sunday. Is that okay? This is the answer. It's not related to 366. Okay. It is a little tricky one. And okay, let's twist it a bit more. I saw this in a DPS Mathura Road, some students shared. What is the probability of 53rd Sunday in a non-leap year? Okay, shouldn't be hard now. 53rd Sunday in non-leap year.
One by 7. Yeah.
Okay, you got it. There are 364 plus 1. That 1 is going to be out of the 7 options. Given we only have 7 days, so that's how it works. By the way, there is no concept of Sunday in India before the Britishers came in 1800 or so. People used to work, and in future people are going to work on Sundays also. It's going to be a new norm. So buckle up. You can take some other days off. Anyway. All right. You can have some profession where kind of maybe mine, but something similar to, have a little relaxed time. Okay, so I think this should be enough for the first this class. We discussed 2-3 things. Okay, I forgot one thing. Yeah, if you note, can we have probability of an event as 1? Yes, no? Nandita? Yes, no?
Maybe.
Sorry?
Yeah.
Maybe, okay. So, probability of event being 1, that means all the possibility, all the favorable outcomes divided by total outcomes. So, it is 1. That is possible, no? Getting 1 to 6 when we throw a die. What's the possibility? Getting numbers 1 to 6 when we throw a die. It is 1 plus 6 by 6. 1. Okay. Getting Sunday after Saturday.
0. 0 possibility.
Getting Sunday after Saturday. 0 possibility.
No, wait. Yeah, one possibility.
You wait. I'm already waiting. You wait and think and answer. Okay. Take your time. I have enough time. Probably you might not have. Okay. So, okay. Can the probability be 0?
Yeah.
Any example? because I'm not really sure.
A probability of 7 after rolling a dice of getting the
Okay,
number
excellent.
7.
So this kind of event is known as sure event, and this is known as impossible event. Getting Saturday after Sunday, okay? That is impossible event. Can we get P of E as minus 1 by 2? Probability of event as minus 1 by 2. Yes, no? 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 Nandita? No. Okay, so democracy wins. It can't be. We are counting the number of outcomes. So number of outcomes are natural numbers, right? It could be one time, zero time. Okay, not whole numbers. Sorry, whole numbers. So it can be. It might not be present. Saturday after Sunday. So zero, or we could have one, two, all these things. But we can't have it a integer. Negative integers. So that's not possible. Is it? Okay, negative is not possible. Can we have greater? Can we have it as 2? Yes, Nandita is saying yes. Shita, no. I couldn't hear you, Shita. You are saying yes or no? Okay, who are
No.
with this? No, okay. Who are with this? We can have probability 2. Raise your hands. No one. Okay. Probability can't be greater than 1. Okay, it can be maximum 100%. So 100% means 100 by 100. You can't have 200 by. That's not possible. Percentage also sometimes you have 200% and all, that's different thing. Point is you have a fraction. If you have a fraction, so fraction can't be greater than 1. Hope that is making sense. You can have zero pizza, or you can have one pizza, or you can have half of pizza, 3/4 of pizza, like that. You can't have, I mean, for one particular pizza you can have 1.5 pizzas, right? It is, although you can have different, but for the same one you can't. So probability can't be. Okay, so the fourth point is that I wanted to reach is probability of any event whatsoever can be equal to or less than 1, or greater than or equal to 0. Fourth point, very important. Probability can be greater or equal to 0. It can be 0, it can be 1, anything in between 0 and 1, because it's a kind of fraction. It's not a rational number, by the way. So from this we'll continue to our next set of questions in the next class. Anyone has any doubts? Should be concerned. Okay, so anyway, you can ask. So we'll continue this in the next class. All right, bye everyone, good night.
Thank you, sir.
Thank you.
Good night.
Yeah.